Hello class, this is a lesson on index notation, or for short, we're going to be learning about indices. And in this lesson we'll be covering what a base is, understanding what an index is. An index is the singular, indices is when you refer to lots of them, and how they increase or decrease, and just a few examples of what they are. So at its most basic, an index looks like the following. If you have some number x to the power of n, that little number there, that is called the index. And this here, this number at the bottom, is called the base. And what this really means is we have x times x times x times x times dot 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 dot, and how many times we multiply it. So if this is 1x, 2x, 3, 4, there are x n number of times. So for example, an example of that, if we have, let's say, 2 to the power of 2, it means we have the base of 2, so remember that's the base, and it's multiplied by itself twice, so that's the index. Right? So it actually is equal to 2 times 2, because there's 2 of them. So there's 1, that's 2, and the base is 2, so it repeats. And as another example, if we do 3 to the power of 2, that's actually 3 times 3, because the base is 3, and it's multiplied twice by itself. And just a few more examples. If we have 4 to the power of 5, the base, once again, the base is 4, and the index is 5. So we say base is 4, and the index is 5. So this is actually 4 times 4, that's 2, that's 3, that's 4, and that's 5. But this also works with pronumerals, or letters. In case you don't know yet, pronumerals are really just letters, but I'm going to be referring to them as pronumerals from now on. Okay, so that's the one we're going to choose. If we had, let's say, x to the power of 6, that is really, so in this one, what's the base? I'm going to ask you just to answer in your head, what's the base? What's the index? Actually, you might see it as an indice. Indice, just so long as you understand what we're referring to. So the base is x. The indice or index is 6. And what this really means is x times x times x times x. 1, 2, 3, 4. That's 5. And that's 6. And just one more example, just to be 100% certain. If I have t to the power of 4, I want you guys in your heads, let me know, what is a base? what's the base, and what's the indice or index. I'm going to be using them interchangeably, whichever one. So the base is the letter, the pronumeral, sorry, T, and the indice is 4. So this is actually the same as T times T, that's 2, that's 3, and that's 4. Okay, so that, we know what the base is, we know what the index and the indice is, and now we're going to see how they increase or decrease. That's out of focus. Hang on, let me fix that up a little bit. There we go. So we know what a base is, we know the index and the indice is. So that is the basic idea of what an indice is. Moving along. So let's see how they increase or decrease. So increase and decrease of indices. Oops. I'm going to be writing in the general sense of what it might look like. Are you ready? If we have some letter x to the power of m times the same base, it must be the same base, x to the power of n, this is equal to x to the power of m plus n. Now I'm just gonna put on the little side here if two numbers of the same base, if two numbers of the same base are multiplied, their indices add. So here we have two numbers, x and x. They're of the same base and they are multiplying. So two numbers, x and x, multiplied, their indices, m and n, add. Now this is all well and good, but this is what's known as the general expression. It'll make a little bit more sense if we have some examples. So I'll give you an example of that. Oh, sorry, this is increasing because it's adding. Let's put that on the little side. This is the increase. What's really adding? It's adding indices. So, for example, if we have, let's say, example one. If we have 2 to the power of 3 times 2 to the power of 4, this will give us, well, because they're of the same base, 2 to 3, 2 to the 4, the bases are the same, 2 and 2. These numbers, the indices, will add. So it's going to be 2 to the power of 3 plus 4, which is equal to 2 to the power of 7. Now, if you're asking yourself, why do they add? Well, I'm just going to put on a little side here, a little side note here. See that 2 to the power of 3? 2 to the 3 is equal to 2 times 2 times 2. Okay, put a little bracket there. That's the first one. Times 2 to the power of 4. Well, times times, in the middle, 2 times 2 times 2 times 2. That is 2 to the power of 4. See? I'm putting them in brackets just to show you that this is the first one and that is the second one. But if we count all of them, well, those brackets, well, they really don't matter. I'm just putting them to show you. But if they weren't there, how many 2's are there? Well, there are 1, 2, 3, 4, 5, 6, 7. That's 2 to the power of 7. So either way we look at it, when it's in expanded form or in short form, you get the same answer. I'll give you one more example. Example 2. If I have, we'll go to the different letters now this time. If I have t to the power of 4 times t to the power of 5, well, they're of the same base. Okay, well, that will just be t to the power of 4 plus 5. Hope you can see that. It's a bit small in the camera. That will give us t to the power of 9. Now, if you're wondering what happens if they're of different bases, so let's say example 3, if they're of different bases, so let's say we have x to the power of 2 times, in focus, yes, y to the power of 3. Okay, it's very important that you know that two numbers of the same base, it must be the same base. If two numbers of the same base are multiplied, their indices add. These two numbers do not have the same base, so these two indices do not add. So all that happens is that they merge together, which is just x, 2, y, 3. They just merge together, but they keep the same base. So this is increasing of indices. Before the video gets any longer, we'll go on to decreasing indices. We'll go on to decreasing, which is really just subtracting. Side here. So, in the most general sense, right, for all cases, if we have x to the power of m divided by x to the power of n, that becomes x to the power of m minus n. And just another example, you might see it as x to the power of m over, which is the same as divide, x to the power of n. It's the same thing because it's still division, just two different expressions of it. It becomes x to the power of m minus n. Okay, so, and the definition, see if you can make sense out of it. If two numbers of the same base, notice again, same base, divide, two numbers of the same base divide, their indices subtract. Indices indices subtract. So here we have two numbers, x and x. If their indices are, if the bases are the same, the indices subtract m minus n. Same thing, x to the power of m, x to the power of n, there's a division, we get m minus n. So I'll give you a few examples of that. So let's take this for example. Example 1, we'll go with 4 to the power of 6 divided by 4 to the power of 3. They have the same base, so it's 4 to the power of 6 minus 3, which will give us 4 to the power of 3. And the same thing, I will show you why it works if you're wondering. So here it is again, 4 to the power of 6 divided by 4 to the power of 3. Okay, so this time is going to be a little bit more complicated. So this is, we know, is the same as 4 to the 6 divided by 4 to the 3. So I'm going to write it in this manner. So it's going to be 4 times 4 times 4, that's 1, 2, 3, 4, 5, 6, over, so that's 4 to the power of 6 on top, and there's 3 in the bottom, so 4 times 4 times 4. By the way, that's called expanded notation. We're expanding everything. Okay? So, if we remember that from fractions, that if we have on the numerator a factor which is also on the denominator, we can cross them off. So, here's 1 4 on the top and 1 4 on the bottom. That's 1 on the top, 1 on the bottom, 1 on the top, 1 on the bottom. I can't cross off anymore because there's none left on the bottom. So what do we have left on the top? 1, 2, 3. So there's 3 on top, therefore it's 4 times 4 times 4. In index notation is 4 to the power of 3. So either way we look at it, it's the same thing. We'll do one more example using a letter. Example 2. We'll go with the letter U. U to the power of 7 divided by U to the power of 3. Well, I hope you get the idea now. It's going to be U to the power of 7 minus 3, like that, which gives us U to the power of 4. That concludes the very basics of index notation.